All right, so well, the purpose of this video is to acquire a way of distinguishing any equation as either being stated explicitly or implicitly. So what we mean here by explicit is that whatever the function output is, whatever the y is stated directly. It's stated exactly, it's stated y equals this, the function value equals that. There's sort of no beating around the bush in terms of what the function outputs are. On the other hand, you have implicit equations, and in implicit equations, the function outputs, the y's, are not stated directly. They're only stated indirectly. A way to think about this would be like, I don't know, say someone came to the door, and say it was like, Uncle Dave or something like this. On one hand, if Uncle Dave came to the door and somebody in your house was like, hey, who was that at the door? You could say it was Uncle Dave, and that would be an explicit way of saying who was at the door. You're saying directly who was there. You could also beat around the bush in your way of talking about Uncle Dave. Say Uncle Dave was your mother's brother, or let's say your mother's youngest brother. Well then, an implicit way to talk about who was at the door, say you come back to your roommate or whatever, and your roommate like, hey, who was at the door? Well, you could say it was my mother's youngest brother. Now, your mother's youngest brother is Uncle Dave, so it's the same person in both cases, but you're sort of saying it a different way. If you're saying Uncle Dave was at the door, you're saying very directly what's happening. And if you're saying your mother's youngest brother, you're saying it in an indirect fashion. It's the same idea, but it's just phrased in a different way. So here's the thing. Functions can be phrased explicitly, functions can be phrased implicitly. And again, the difference is the function output, is the y stated exactly, or is the y stated in a roundabout way? So the easiest way to see this is your y isolated on one side and y equals this? Every explicit equation is of the form y equals something. And to be clear, that something involves nothing with y. So y equals x squared plus 5x minus 6. This is of the form y equals, and what y equals has nothing to do with y. That is explicitly stating what the output is. The output is x squared plus 5x minus 6. Here, we've got something in the form of f of x, but so be it. F of x is equal to this. F of x is your y, as you know, and this has nothing to do with y. There's no y's, there's no f of x's, it's just cosine x squared plus 2x plus 5. Here is what y is, and what y is has nothing to do with y. G of x is equal to e to the x cosine x. Here is something where y equals this. This does not involve y. This is stated directly. Now, this may be a product of functions. If you were taking the derivative, you'd need to use the product rule. No sweat. But the long story short is this is explicitly stated. P of x is x squared plus 5x divided by sine of x. That is an explicit expression because the function output is by itself, the p to the x, and what's on the other side has nothing to do with p to the x, nothing to do with y, nothing to do with the function output. The function output is this, and what this is has nothing, does not in anywhere in its expression have an expression of the function output. It is just something in terms of x, something in terms of x, something in terms of x. Now, the implicit functions are a little bit different, because when you look at the implicit function, what you're going to notice is that you're going to have y's scattered throughout the expression. So look at this first implicit equation. You've got yx squared equals x plus y squared plus 5. You've got y scattered throughout. You don't have something of the form y equals, where what y equals has nothing to do with y. That is not the case here. You could try to get y by itself by moving the x and the 5 to the other side, but you'd still have a y on the other side. So this is not explicitly stated. Here is another expression that is not explicitly stated. Why? This is not in the form y equals. This is of the form what? Y squared x equals x cubed. This is implicitly stated. To be explicit, you'd have to have y equals something, f of x equals something, g of x equals something. Here, y is not by itself. Because y is not by itself, and because what's on the other side is not just in terms of some other variable, this is not an explicit expression. This is implicit. Here we have x squared plus y squared equals 1. Not of the form y equals, not explicit. So it's implicit. And sort of just to emphasize that implicit equations, can be important. You've seen, presumably, x squared plus y squared equals 1 before. This is the unit circle. This is the equation for a circle of radius 1 centered at the origin. And this is like an equation where you could look at the solutions, and you could graph the solutions, and you'd get something that is like a perfectly reasonable picture of solutions to look at. This equation is not an explicit equation, but it's an equation nonetheless that has importance. Hell, you know that sine, cosine, you can derive from the unit circle. So certainly an equation like this has importance and meaning. This last example of an implicit equation is almost a deceptively implicit equation, because you could say, oh, look at this, it's y equals something, it must be explicit. No, not so fast, because look at this expression, y equals 10x plus 5x squared minus 3y squared. An explicit equation is of the form y equals dot dot dot, where all of that dot 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 does not involve y. Here, y equals something involving y. That is an indirect way of stating what y is, so that is an implicit expression. Anytime you've got y scattered throughout your equation, anytime you don't simply have y equals something, where that something does not involve y, you've got an implicit equation. And well, what we're going to talk about next is, like, we have a heck of a lot of ways to take the derivative of explicit functions. You could go straight at this function. This function would require the chain rule to take its derivative. Here, the product rule. Here, the quotient rule. We've got a bunch of ways to take the derivative of a function stated explicitly. But how are we going to deal with functions implicitly? We'll answer that here in a bit.